Hey everybody, so today we are talking about net ionic equations. So today you're going to be able to take a complete molecular equation like this one and then break it down to just be a net ionic equation. But first of all, what is a net ionic equation? As it says here, it is a reaction that only focuses on what makes a precipitate. So it's a reaction that only focuses on things that make a solid, things that make a liquid, or things that make a gas. Again, this is not a net ionic equation. This is a complete molecular equation. So I just wrote this out to demonstrate what is happening in these beakers down here. First, what we're doing is we're mixing potassium chloride and lead nitrate. So we're putting those together in this beaker. As you can see, I have 2 KCls and 1 lead nitrate, like I have in my reaction part of my reactant side of my reaction. And then what happens is, since both of those are aqueous, they split apart into their ions. K is going to break up into 2 K pluses and 2 Cl minuses. PbNO3, 2 aqueous, is going to break up into Pb2 plus and 2 NO3 minuses. So whenever you see aqueous, that means they just break apart in water, okay? So they don't stay whole like this at all. They actually break apart into these nice little ions. And then what happens is that when we get to this side, we get 2KNO3 aqueous, which means that, remember, those ions are floating around. And I should actually have one more NO3 in my beaker here. So that means I have potassium and nitrate ions floating around. And then here you can see I have a lead chloride solid, which forms as a precipitate on the bottom of the beaker. So all of this happens in an instant. As soon as those ions get in the water, they're starting to break apart or dissociate or dissolve, and then instantly they're forming together with ions that have opposite charges, so they could either form a solid or stay in that aqueous solution. So today what you're going to be doing is just making the reaction that focuses on the solid. So let's go ahead and let's make the net ionic equation for this guy that I wrote up top. Let's get rid of these beakers. So that was just kind of a visual demonstration on what's actually happened in this reaction, but now we're getting to the actual problems that we are going to be seeing on our exams. Okay? So what we're going to do is we are going to break apart everything that is aqueous and keep everything together that is a solid, liquid, or gas. So let's look at this guy. We got to break him apart. As you saw in our beaker, it's going to break apart into its 2 ions, K plus and Cl minus. So when this breaks apart, it's going to break up into 2 Ks because of the 2 in front, and it's going to be aqueous. And this is going to break up into 2 Cl minuses, which is going to be aqueous. Right? Again, I put 2 in front because there's a 2 in front of that whole reaction. You have to include the state, which is aqueous, and you have to include the charge. It's a pain, but you got to, okay? For this guy, it's aqueous, so I'm going to split it apart as well. There's just 1 Pb here, and it has a 2 plus charge. Because nitrate, I have 2 nitrates here that have a -1 charge. So I'm going to put 2 nitrates that have an aqueous charge. Again, we are splitting up all our compounds that are aqueous. Okay, so that's the reactant side. Now we're going to the product side. This is aqueous, so I'm going to split it up as well into 2K plus aqueouses and 2 NO3 minus aqueouses. Okay, I'm going to move this so you can see it. So again, 2 in front, so I got to have 2 K pluses and 2 NO3 minuses. And then the solid, remember, we only split up things that are aqueous. Things that are solid, liquid, and gas we keep together. That is a solid. So it does not split up. It's going to form a nice precipitate at the bottom of our beaker. So that is your first step. Your first step is just splitting up everything that is aqueous, making sure you got the right coefficients in front, and the right charges and the right states. The next thing is you just cancel out things that are the exact same on both sides. So you will take, if you see any ions that are on the reactant side that are the product side, you're going to cross them out. So examples of this are my K plus. They are the exact same on both sides. Another ion that is the exact same is 2NO3 and 2NO3. Those are the exact same. You have Cl minus over here, and you have Cl. Those are not the exact same, okay? Those are different. This is a chlorine ion. That is chlorine when it's attached to a lead. So again, only if they're the exact same are we crossing them out. Those are known as spectator ions. They don't do anything. They don't react. They're just kind of a delivery system. K helps us get the Cl into the beaker. NO3 helps us get Pb into the beaker, and then they react and form that lead chloride. And then whatever is left over is our net ionic equation. So 2Cl minus Aq plus Pb2 plus Aq to PbCl2 solid is our net ionic reaction, our net ionic equation. And that's it, okay? That might have been a little confusing. Let's do a few more before we decide to end this, okay? So let's do another net ionic equation. Into the dry erase zone, as they say. Okay, so let's say I have lithium chloride, which is aqueous. I have silver nitrate, which is aqueous, and it's going to form silver chloride, which is going to be a solid, and lithium nitrate. That is a horrible nitrogen. Nitrate, which is going to be aqueous. Right, so this is our complete molecular reaction. Let's go ahead and start doing our net ionic equation. So we're going to split up everything that's aqueous. Lithium chloride is aqueous, so it's going to break apart into lithium plus Aq and Cl minus Aq. There's not a 2 in front, so I don't need 2 of them. There's not a 2 down here, so I don't need 2 of them in my split up reaction. AgNO3, it is aqueous, so I'm going to split it up into Ag plus Aq and NO3 minus Aq. Now I'm on the product side. AgCl solid, do I split him up? No. It's a solid. It stays together, right? And then last but not least, I got lithium nitrate over there. Do I split it up? Yes, it is aqueous. So it'll be Li plus Aq and NO3 minus Aq. So that is our first step, and then our second step is just crossing out things that are the exact same on both sides. Looks like I got a lithium and a lithium. Looks like I got a nitrate and a nitrate. They are spectator ions. They're just delivery systems. Lithium helps us get the chlorine in. Nitrate helps us get the silver in to form our overall net ionic equation of Cl minus Aq plus Ag plus Aq and AgCl solid. That is our net ionic equation. Hopefully that's getting a little better. Let's go ahead and do another one. Let's go ahead and do an acid-base reaction of, let's go H2S, let's go sodium hydroxide. These are both AQ. Most strong acids and bases are aqueous, which we will talk about another time. H2O liquid, and let's go with Na2S. And let's balance this guy out. And we'll say sodium sulfide is aqueous. Usually most things with sodium are aqueous. So we're looking at this, and now it's time to break it apart. Okay? Is H2S aqueous? Yes. It's going to break into its ions of H plus and S2 minus. But there's a 2 here, so we're going to have 2 H pluses. Not just 1, but 2. And then sulfur, which has a 2 minus charge. There we go. Sodium hydroxide, is it aqueous? Yes. It's got a 2 in front of it, so it's going to include 2 sodiums and 2 hydroxides. Product side, H2O, do we break that apart? Nope, it's a liquid. It's not aqueous. It's not aqueous, right? Aqueous is the only one we split apart. So since it's a liquid, we keep it together. And then the last one, Na2S, it's the aqueous, yeah, so we split it apart. It's got a 2 right there, so that means it's going to have 2 sodiums and 1 sulfide ion. Time to cross out things that are the same on both sides. I see a S2 minus and an S2 minus. I see a 2Na plus, 2Na plus. That's it. Spectator ions were S2 minus and Na plus. So what we have left is our net ionic equation, which is 2H plus aqueous, 2H minus aqueous, and 2H2O liquid. And if you wanted to, I won't count you wrong if you leave the 2's in there, but you should reduce these. Since they're all 2 in front, let's just go ahead and reduce it so they're all 1 in front. Okay, again, if you leave the 2's there, I'm not going to be too picky about it, but if you get into further chemistry, if you leave those on there, somebody's going to give you some grief about that. Let's do one more that's a little trickier. And I'm going to make it up just right off the top of my head. Let's go strontium chloride, which actually is a solid. Let's go, let's go potassium bromide, which is aqueous, I believe. And it's going to make SrBr2, which is a solid, and it's going to make KCl, which is aqueous. Balance this bad boy out. 2, that's good. Okay, so now you could see that we have a solid on the reactant side and on the product side. Well, don't let that trip you up, okay? Still follow your rules. Just actually makes it less work for you. SrCl2, do we split it up? No, it is a solid, which means when we put it in that beaker, it's not really going to dissociate. It's going to dissociate or dissolve a little bit, but not a whole lot. KBr, aqueous, do we split it up? Yep. Since there's a 2 in front, I'm going to have 2 K pluses and 2 Br minuses. Strontium bromide, do I split that up? No. It's a solid. And then KCl, okay, aqueous, we split it up, 2 K pluses, AQ, and 2 Cl minuses, AQ. And hopefully you can see that. You can. You can. And then this looks kind of crazy, and you're thinking, oh boy. But just follow your rules, okay? Things are the same on the both sides. We're going to cancel out. So we're going to cancel out these 2 K pluses. And that's it. Really, the only thing that was a spectator ion was K+. It was just a delivery system. And it helped us get our Br in there. All right? So then our net ionic equation is just our remainder, which is SrCl2 solid, these 2 bromine ions, this SrBr2 solid, and our 2 chlorine ions. So bromine wasn't much. He was just a delivery system in the beginning, but later in the reaction, he ended up becoming our precipitate. Whereas later, chlorine ended up not being much of anything in the end. But we don't cancel it out. We still leave it there. So that is net ionic equations. Now you should be able to make an equation that just focuses on what makes a precipitate, what makes a solid, a liquid, or a gas. So that is it. Pretty short lesson. Make sure you're checking out that practice. Let me know if you have any questions. Have yourselves a great day.